Let's also use completing the square to write a quadratic function in vertex form. Now, when we solved equations, we were solving an equation, and so we could do things to both sides of the equation. Here we're rewriting an expression. We're rewriting the expression for this function. So we don't have both sides. We need moves that keep the value of our expression the same. We need moves that give us an equivalent expression. And so we're going to introduce a brand new simplifying move that we haven't seen before. And that is, we can always add and subtract the same thing without changing the value. So if we have some expression, we can add and subtract the same number without changing the value. But then we have that extra number sitting there and we can maneuver with it. And it's easy to see why this won't change the value, right? This cancels out. That adds up to 0. So this amounts to adding a funny looking 0. But as we'll see, that is going to be really useful for us in getting that constant we need when we complete the square. Rewriting in vertex form is easier if our quadratic function has leading coefficient 1. So we're going to go through an example of that first before we see what the whole process looks like. So here we have a function f of x is x squared plus 12x minus 7. And the square we want to complete has our x squared plus 12x in it. So x squared plus 12x plus something is going to be x plus something squared. I'm going to draw the square, split it up so that I have a big square in the top left, a small square in the bottom right, and then the two smaller rectangles. My big square, I've got an x squared, which is x by x. My smaller rectangles, I want to divide 12x evenly between them. So I'll take 12 divided by 2 is 6, and I'll put 6x in each of these rectangles. So the remaining side has length 6, which means that my small square must have area 6 times 6 is 36. My missing piece is a 36, and the square that I'll have is x plus 6 squared. So what I want to do in order to introduce my missing term is to add plus 36 minus 36. I'm adding and subtracting 36 at the same time. I'll have my expression as x squared plus 12x plus 36 minus 36, and then keep the minus 7 that I had before. And the reason that I wanted to do that is now I'm going to group those first 3 terms together. Those first 3 terms together are the perfect square that I got by completing the square. So those first 3 terms together are x plus 6 all squared. And then I can also combine these last 2 terms. I have a negative 36 minus 7. So those combine to give me negative 43. So that's my function in vertex form. F of x is x plus 6 all squared minus 43. To find my vertex then, I notice that x plus 6 is x minus negative 6, which means my h is negative 6. Looking at the equation, my k is negative 43, and so my vertex has coordinates negative 6, negative 43, which is probably not something that we would have guessed without doing this rewriting. Okay, so that's rewriting in vertex form. We complete the square, we add and subtract the constant that we need, and then we regroup terms. It gets very slightly more complicated when we have a leading coefficient, so when the coefficient of x squared is not 1. The algebra just requires a little bit of care from us. So here's what the process looks like. So we're starting with g of x is negative 2x squared plus 8x minus 5. And the first thing we're going to do is put in a set of parentheses to group the variable terms. So that negative 5 is just going to hang out for a while, watching the rest of this happening. The negative 5 is going to not be involved for a little while. Next, we're going to factor out the coefficient of x squared. So we're going to factor out a negative 2. G of x is negative 2 times, here we've got an x squared, here we've got an 8 divided by negative 2, so we'll have a negative 4x. And then we've got minus 5. Okay, so far so good. But now it's time to complete the square. So the thing we're going to complete the square on is x squared minus 4x. We'll fill in a constant there, and that'll be x minus something squared. Drawing my square and splitting it up so I have a big square in the top left, a little square on the bottom right. I've got x squared, which is x times x. And then my little rectangles, I want to split negative 4x evenly. So I'll say negative 4 divided by 2 is negative 2. And I'll have negative 2x in each little rectangle, which will give me a negative 2 here, a negative 2 here, and my missing piece in the bottom right corner is negative 2 times negative 2 is 4. So my missing piece is a 4, and I got that from x minus 2 all squared. Going back to my function then, g of x is negative 2 times x squared minus 4x, and then I'm going to add and subtract my constant, plus 4 minus 4. And then that negative 5 is going to just sit there and stare at us for a while. My g of x is negative 2 times, here I'm going to group these first 3 terms. So I'll have x minus 2 squared, and then I still have that minus 4 inside the parentheses, and the minus 5 outside. All right, so I'm just looking at which terms have I already used. Any terms I haven't dealt with have to get copied. Now it's just a matter of cleaning up. So notice I have one complicated term and one simple term inside the parentheses. I'm going to distribute this negative 2 to those two terms. So my g of x, I'll have negative 2 times x minus 2 squared. And then I'll have negative 2 times negative 4 is positive 8. And then the minus 5 is still hanging out. Finally, I'll combine those two constant terms outside the parentheses, and I'm left with g of x is negative 2 times x minus 2 all squared plus 3. And that's it. That's my function. Looking at what I've written, it's easy to see that my h is 2, my k is 3, and so the vertex, if I were to graph this, will be at 2, 3. Not as terrible as it seems at first, right? As long as we remember that add and subtract the same thing maneuver that we used to complete the square, and as long as we work patiently and sort of follow our nose through the algebra, it's not too terrible.